we are now going to look at 11.9 section, which is on page 317, and we are going to be looking at the trapezium rule. Okay, now this is a rule that you can use to find the area under a function if you cannot integrate it algebraically. Okay, now the reason for that might be that the function is too complicated and you can't use any of the methods that you've learned to integrate, so you can find an approximate area by using the trapezium rule, okay, between two limits. Let's say they are a and b. Now the way to do that is by splitting the area under the curve between the two limits into strips, and as you can see, each strip is approximately, it looks a bit like a trapezium. Now obviously that's the reason why we say approximate, is because of these bits that we're going to miss out, or here that we're going to overestimate, okay, because we are going to be working out this area of the trapezium, and this area is actually not included. But you know, there are several ways of making this area as accurate as we can do by having as many strips as possible. Okay, so if we increase the number of strips and the thinner they become, the more accurate the area we will get of each of these trapeziums. Okay, now what we do is we split the area between A and B into trapeziums, and let's say that we've got n number of strips. So here we've got 1, 2, 3, 4, 5. Okay, each strip must be of the same width. Okay, and we call that h. We represent that by h. Now there is a formula that we use to do this, and that formula is given in your formula book, and I'm going to go through that with you in a minute. But I'm just sort of going behind the idea of trapezium rule. Okay, so essentially it's splitting your area in trapeziums between the two limits, and making sure each trapezium is the same width, and that we know the number of strips that we are going to be splitting this up into. Okay, now what happens is, let's just look at this first trapezium strip that we've got here. So it looks a little bit like this. So we've got, let's say this height is y0, this height is y1, and the width of the strip is h. Now if you remember from GCSE, the formula for area of a trapezium is half times y0 plus y1 times by the distance between the two heights, okay, which is going to be h. Alright, so now imagine if you've got 1, 2, 3, 4, 5 different strips, okay, and if you were trying to work out the area of those, this is what you would have to do. You would, so that area would approximately be half h, area of the first trapezium, okay, plus half h, area of the second trapezium, okay, then half h, area of the third trapezium. And if I carry that on, as you can see, I've got y0 appearing just once, y1 appearing twice, y2 appearing twice, and then the last height is only going to be coming up once. So this is y0, y1, y2, y3, y4, and this is y5. Now y5 and y0 only appear once, and all the middle heights actually appear twice. Okay, so if I was to simplify this formula, then I would actually get something like this. Half h would come out as a common factor, and I will get y0 plus y1 plus y1 plus y2 plus y2 plus y3 and so on, and then I will just have y5 only once. Okay, so there's another way that I can simplify this formula, is by saying half h y0 plus 2 times y1, y2, y3, y4, and then just y5 only once. Okay, if I'm looking at this particular example. So this is essentially what my formula looks like. Okay, a more general version of it So let's write that down, the one that's given to you in your formula booklet. A more general version of this formula is half h y naught plus 2 times y1 plus y2 plus whatever your second last height is plus your last height, which is actually the y value, the last y value. So this is the formula that we're going to use, okay? And your h is found by knowing the two limits and by knowing how many the number of strips. So actually this is n, okay? So b minus a divided by n will give you the width of that strip. Now let's actually have a look at an example. So we've got a curve, page 318. We've got a curve that looks a little bit like this. This is 1. This limit is pi by 3. Function is y equals sec x, and I want to find this area using the trapezium rule, okay? It says complete the table with values of y corresponding to pi by 6 and pi by 4. So they've given a table which I've got to complete, giving your answers to 3 decimal places. Okay, so this bit is quite simple. We've got a table. Let me draw this table. Okay, really quickly. Okay, so if you plugged in pi by 6 and pi by 4 into the function, which is sec x, so if you worked out sec pi by 6, and you would do that by working out cos pi by 6 and then take a reciprocal of that, approximate value of that to 3 decimal places would be 1.155. And then similarly, if you worked out sec pi by 4, you would have to do 1 over cos pi by 4, and an approximate value would be 1.414. So put in those values, 1.155 and 1.414. Okay. Next part of the question says, use the trapezium rule with all the values of y in the completed table to obtain an estimate for the area of R, giving your answer to 2 decimal places. Okay. And the number of strips that we have, now let's work that out. Let me show you how you do that. So you've got 0, you've got pi by 12 somewhere here, pi by 6 somewhere here, pi by 4 somewhere here, and then you've got pi by 3. So that's 1, 2, 3, 4. So if you've got 5 values here, you'll have 4 strips there. Okay. So your h is going to be, let's work out our h, is going to be pi by 3 divided by 4, and that gives you pi by 12. Okay. And now let's plug this into our formula. So area between, we're trying to work out area between 0 and pi by 3 of this function. That will be half times h. Let's just write down the formula once again. 2 times y1 plus y2. So y1 plus y2 plus yn minus 1 plus yn. Okay. And this will be half times our height times, and now y naught is 1, okay, which is this value. This is, sorry, on the graph, this is y naught, this one. So 1 plus 2 times these 3 values in the table. So 1.035, because these are all the middle heights. And then at the end we write plus and the last value, which is 2, and then put that all in a bracket. That's gonna give us pi by 24, and when I add up all of these values here, I am going to get 10.208. Okay, and then I want my answer to 2 decimal places. That's what they're asking for, and that is 1.34 to decimal place. Now the question says, explain with a reason whether your answer to part B is an overestimate or an underestimate. Now imagine if I was forming my trapeziums here. Just look at that. Just look at what's happening if I was to draw these straight lines. My area of my trapezium is always more than the area that I'm after, okay? So I'm actually going to be getting an overestimate. This answer is an overestimate, okay? So I need to write that down. The answer, this is always a 1-mark question after a trapezium rule question, okay? They always ask you this, mostly, from what I've seen. So the answer would be an overestimate. And the reason is the graph is convex, okay? So the lines connecting two endpoints will be above the curve. Okay? And hence we are going to get a greater answer than what it is originally. Okay?